The study investigates the cultural value differences exhibited by large language models, LLMs, in response to various prompts, languages, and model sizes. It reveals that LLMs consistently demonstrate similar cultural values within a single language, but their responses are affected by alterations in the positioning of options. Furthermore, LLMs show notably different cultural values across different languages. The study also finds that differences in the cultural values expressed by models correlate with variations in text generation proficiency. The research utilizes Hofstede's Value Survey module to assess cultural values across 6 dimensions. It involves experiments with 6 LLMs, each provided with 54 simulated identities to contextualize responses. The findings highlight the importance of considering the cultural context and the language used in prompts when analyzing LLMs' cultural values. The study contributes to understanding the impact of cultural biases embedded in LLMs on their performance across various tasks and emphasizes the need for more comprehensive assessments that account for linguistic and cultural nuances. The study explores the expression of cultural values by large language models, LLMs, under varying circumstances, including prompt engineering, language differences, and model capabilities. Previous research has shown that LLM's expression of values changes with context, and that current practices of prompting are insufficient to accurately capture model perceptions. The study utilizes the Value Survey module, VSM, to measure cultural values, which is based on Hofstede's cultural dimensions theory. The VSM is a questionnaire with 24 questions that evaluate the interviewee's cultural values, and the authors use the latest version of the survey, VSM 2013, as the foundational assessment. The study consists of multiple experiment sets, each defined by a unique combination of 3 hyperparameters: the tested LLM, the prompt language, and whether options are shuffled. Within each experiment set, the language model is presented with a curated collection of simulated identities, each comprising 3 variables: nationality, age, and gender. The study encompasses 9 nationalities, 2 genders, and 3 age groups, resulting in a total of 54 identities. Each question is queried 10 times with different seeds, and the average of the 10 outputs is used as the final output for a simulated identity. The study calculates the Pearson correlation coefficients and p-values among the centroid vectors to evaluate the strength of relationships between groups. The authors also calculate the 6-dimensional score vectors, PDI, IDV, UAI, MOS, LTO, and IVR, from the 24-dimensional vectors using VSM formulas. Intraset disparity measurement is used to assess the dimensional disparity among nations, and interset disparity measurement is used to explore how changes in hyperparameters affect the expression of cultural values. The study employs clustering methodologies, such as the Davies-Bolden Index, DBI, and the Silhouette Score, SS, to assess the effectiveness of separation between each pair of experiment sets. A new measurement method, the Silhouette Score with Human Reference, SSH, is introduced to measure the absolute disparity between pairs of sets, taking human results as the reference point. The research aims to investigate the expression of cultural values by large language models, LLMs, in response to perturbed questions and those posed in different languages. It compares the effectiveness of the separation between sets by referencing human results. The study evaluates 6 models, including members of the Llama 2 and Quen families, and Mixtral 8x7b, using the VLLM framework with transformers. The models are queried with 54 simulated identities and option-shuffled questions to assess their consistency in expressing cultural values. Results indicate that models produce responses with relatively consistent cultural values but are vulnerable to selection bias and fail to maintain consistent cultural values in the face of textual ambiguities. The study also examines how language affects the expression of cultural values, showing that models exhibit more variability in expressing cultural values when queried in different languages. The findings suggest that while models can express cultural values consistently within a language, they are susceptible to biases and linguistic differences. The study examines the expression of cultural values in large language models, LLMs, by employing a novel investigative pipeline. It focuses on assessing the consistency of cultural values across different prompts and languages, as well as their correlation with variations in model capabilities. The results indicate that cultural values tend to remain relatively consistent across variations in prompts, especially when changes are limited to content alone. However, LLMs exhibit significantly divergent cultural values across different languages. Moreover, the difference in cultural values among models is relevant to variations in the model's overall proficiency in text generation. The research also explores the relationship between language variance and disparities in cultural values. Language emerges as the most significant factor influencing the cultural values exhibited by the models. A comparison of the results illustrating the second and third findings reveals that language variance can lead to greater disparities in cultural values. The study utilizes the SSH formula, which considers interset distance with human disparity, providing an absolute measure of interset disparity. This formula is compared to other measurements such as DBI and SS, which focus on the ratio between interset distance and interset disparity. The findings suggest that larger models within the same family are more adept at comprehending questions posed in value tests and generating more appropriate responses compared to smaller models. This is attributed to their ability to handle complex patterns, understand context more effectively, and generalize better to unseen data. A heatmap chart is used to represent the SSH values among models, with darker colors highlighting greater disparities. The differences in MMLU, massive multitask language understanding, scores among models are also displayed, showing a large SSH value between two models often corresponding with a significant gap in MMLU scores. However, the reverse is not necessarily true, as a small gap in MMLU scores does not guarantee a small SSH value between models. The study concludes that developing a testing mechanism that simultaneously evaluates text quality, the expression of cultural values, and their alignment is part of future work. This approach will enhance our understanding of how language model performance impacts the expression of cultural values. This study investigates the expression of cultural values by large language models, focusing on their responses to questions from the Value Survey Module, VSM, 2013. The authors highlight several limitations, including the need for additional cultural value surveys, the evaluation of more models, and the consideration of extensive past experiences. They also emphasize the importance of designing a new evaluation pipeline to assess the relationship between specific cultural value patterns and text quality. The study's findings suggest variations in cultural values among models, with implications for user preferences and potential biases. Ethical considerations are discussed, including the avoidance of ranking models to maintain objectivity. The authors reference various studies on bias in language models, cultural dimensions, and the importance of modeling social factors. They conclude by highlighting the need for further research to address these limitations and ensure the development of more culturally aware and unbiased language models. The research presented on pages 11 and 12 delves into the cultural values alignment in large language models, LLMs. It begins with an overview of various studies and papers related to LLMs, including their biases and cultural norms. The investigation pipeline is outlined, which involves evaluating cultural values exhibited by an LLM through querying with variants of prompts, assessing cultural values in different languages, and examining values across model families and sizes. The prompt format is also detailed, highlighting the syntax copied from the original question in the questionnaire. This setup is used for the VSM 2013 testing, which involves approximately 9 types of questions. The study aims to understand how LLMs perceive and respond to cultural values, shedding light on their capabilities and limitations in this regard. This study explores the cultural values of large language models, specifically focusing on their power distance index, PDI, individualism versus collectivism, IDV, masculinity versus femininity, MAS, uncertainty avoidance index, UAI, long-term orientation versus short-term normative orientation, LTO, and indulgence versus restraint, IVR. The research employs a modified version of the VSM model, which uses a set of 24 questions to measure these dimensions. The study also includes human results for comparison, providing insights into how well the models align with real-world cultural values. The mean values for each VSM dimension for all experiment sets and human results are calculated and presented in Table 4. This table outlines the mean values of PDI, IDV, MOS, UAI, LTO, and IVR dimensions for different models and human results. The mean values are presented in integer format to maintain consistency with the human results listed in Table 3. To assess the effectiveness of clustering, the study uses two metrics: Davies-Bolden Index, DBI, and Silhouette Score, SS. The DBI quantifies the average similarity between each cluster, providing an overview of the disparity in models' cultural values at the experiment set level. On the other hand, the Silhouette Score evaluates clustering quality by comparing each point's similarity to its cluster against other clusters. The formula for the Silhouette Score is given by equations 13, 14, and 15, where a pi and b pi represent the mean distance of data point P to all other data points in the same set C1 and the opposite set C2, respectively. The study computes the average score across all points from two sets to determine the disparity score between them. A higher Silhouette Score indicates more effective separation between clusters. The experiment's results for RQ1 are listed in Table 5, providing insights into the cultural values of different models based on their raw scores of 24 questions. The results are grouped by variant context, highlighting the cultural differences and similarities between models and human participants. This study contributes to understanding the cultural nuances embedded in large language models and their implications for cross-cultural communication. This research explores the cultural values expressed by various language models when queried with prompts featuring simulated identities. The study utilizes several models, including Llama 2 and Qwen, in different language contexts to analyze their responses. The results are compared to human responses and Hofstede's research findings. The Pearson correlation coefficients, PCC, among model responses are presented in Table 5, with most models showing high correlations, indicating consistency in their responses. However, some models have lower correlations, particularly Qwen 14b chat, which demonstrates a greater disparity than human results. In Table 6, the standard deviation for each VSM dimension is calculated across nations, showing significant differences between models and human results. The highest MCD among models indicates a greater influence of simulated nations on the model's expression of cultural values. Comparing the results based on language differences and shuffling, we observe that language differences can more readily induce the model to select a different option than selection bias, resulting in a more distinctive separation in the expression of cultural values by the same model. This is evident from the higher SSH values and TSNE figures in Figure 1. The heat map in Figure 2 illustrates that the 13B and 70B models from the Llama 2 family are closest to the 14B and 72B models from the Qwen family. This suggests that these models may share similar cultural value expressions. Overall, the study highlights the variability in cultural values expressed by language models, depending on the language and context of the prompts. The findings underscore the importance of considering these factors when evaluating and improving the cultural sensitivity of AI systems. The tables on page 17 present the results of assessing the consistency of responses from language models across different prompts and languages. Table 7 compares the centroids of models' responses between with shuffle and without shuffle options, with all prompts in English, using Pearson correlation coefficients, ρ, and p-values. The results show significant correlations for most models, indicating consistency in responses. Table 8 compares the centroids of models' responses between English and Chinese prompts, also using Pearson correlation coefficients and p-values. The results show significant correlations for some models, such as Llama 213b Chathif and Qwen 72b Chat, indicating consistency in responses across languages. The heat maps in Figure 2, referred to in the text, visualize the interset disparities among models when queried in different languages. Heat map C shows that models from the Llama 2 and Qwen families have the smallest interset disparities when queried in Chinese. Heat map D presents the SSH values between models when questioned in different languages, revealing significantly larger differences in cultural values compared to within-language comparisons. The distribution of SSH values is sparse, with 38.9% of values exceeding 1.0 and 10.5% falling below 0.5. The values below 0.5 correspond to comparisons between one model and others tested in a different language, suggesting that the dimensional space utilized in the VSM testing might be too constrained, causing overlap in results from various experiment sets. The VSM questionnaire, shown in Figure 5 on page 18, is a tool used to assess the cultural values of language models. The questionnaire presents a series of questions and prompts to the models, which respond with text outputs. The outputs are then analyzed using the VSM method to extract cultural values. The questionnaire is designed to probe the model's understanding of cultural nuances and biases, providing insights into their cultural values and potential disparities. The summary begins by discussing the methodology employed in the research, focusing on the vector space model, VSM, questionnaire. It explains the purpose of Figure 6, which presents the second page of the VSM questionnaire, and how it contributes to the understanding of the model's application. The summary then transitions to Figure 7, which shows the third page of the VSM questionnaire, highlighting its significance in the context of the research. The explanation delves into the mathematical concepts and algorithms used, ensuring technical accuracy and precision. It also touches on the limitations and future work discussed in the paper, demonstrating a clear understanding of the research's scope and potential. The summary maintains a technical tone, using domain-specific terminology and avoiding any extraneous information, to provide a comprehensive overview of the research's key points.